Here's the I can statement for 4.2 part 2. I can evaluate functions using function notation. So remember, we introduced what function notation was last time, and it's a really slick way so everybody knows we're dealing with a function and everybody knows what number we need to plug in, or what the particular variable is, the independent variable as we call that. So in the warm-up it says state the domain using interval notation and evaluate the function. So think back to yesterday when we were talking about domain issues. The only domain issues that we're aware of so far, the only things that cause problems when we try and operate them in a function is if we've got division, we can't divide by 0, and if we've got an even root. So let's take a look and see if we've got either one of those. You can see we've got a fraction bar right here, and in the denominator is a variable. Now, I'll give you this. This is kind of a weird variable. This is the Greek letter alpha. It doesn't matter what symbols we use. Letters, the common letters that we use, those are just nice and convenient. But this is Q of alpha equals 2 times alpha plus 1, and then divided by alpha minus 3. So the only thing that wouldn't be okay is if that denominator is equal to 0. So if I were to take alpha, kind of looks like a little fish type figure, minus 3 and set it equal to 0, I just need to solve that. So I would add 3 to both sides. So alpha equals 3. So if I plugged in a 3, I'd have 3 minus 3 on the bottom. I'd have a 0 in the denominator, and I can't have that. I can't divide by 0. So this is the one thing that's not okay. So here's what we're going to say for the domain. So the domain on this one is from negative infinity to infinity, and I realize that symbol's kind of funky looking, except for, so we say alpha not equal to 3. So there's the domain. Now, if we want to find Q of 8, what we do here is we actually plug this in. So wherever there's an alpha, instead of an alpha, we're going to put an 8. So this is going to be a 2 times 8 plus 1, and then we've got an 8 minus 3. So we end up with Q of 8 equaling, let's see, this is 2 times 8, that's going to be a 16 plus 1. So that's 17 over 8 minus 3, that's going to be a 5. So that's it right here. So we've got the function value at 8. Gosh, that looks an awful lot like a Q there. I got to be careful. The domain is right here. And then the other thing that we could maybe be aware of is that this point, 8 comma 7 fifths, 17 fifths would actually be on the graph. So I'm going to put on graph right here. Okay, so that's just kind of a quick review of domain issues and function notation and stuff like that. So the other thing that we need to be able to do, along with finding the function values from function notation, from those equations, from the original functions there, is that we also need to be able to find them from a graph. And it turns out that this is pretty easy to do, but some people get a little bit confused. So we're going to make sure that we go over this in detail. So make sure you pay attention to what's going on here. And if you've got questions, make sure you clear them up, because this is a really important thing that some people struggle with. So it says state the domain and the range, then find the requested function value. And it says, please note, unless we're told otherwise, like we might be below, we'll assume that graphs extend beyond the edges even without the arrows. So if you take a look at this one right here, we've got a closed circle right here, which is pretty clear what they mean by that, and then an arrow on this end. We don't have an arrow on this end, but we don't have a closed circle right there. So that would continue on in that direction. And then same thing for these guys right here. So this curve would continue kind of going up and out, kind of like this big U shape or whatever. Okay, so the domain on this one, again, for domain, if we've got a graph, we squish it onto the x-axis. So these would all come up here. These would all come down here. So we would go forever in this direction. We could just keep going there. So the domain on this one's going to be from negative infinity all the way up to and including, because 8 could come right down here, all the way to 8. So we're going to do a round bracket around negative infinity and then a square bracket around the 8, because that one is included. And then for the range, we're going to come over here like this. We're going to squish it onto the y-axis, because remember, the domain are the x's and the range, those are the y's. And then we'll squish these over here. It's going to go like that and continue down in this direction. So we always start way down here, and we could go as far down as we want here. So this would be from negative infinity, and then we would go all the way up to, let's see, that's 8, 9, and 10. So this would be negative infinity, negative infinity, and then think about where we would end. We would end at 10, and it is included also. And then the last thing we want to do is we want to figure out the function value at 8. So we want to figure out f of 8. So notice that this point right here, that big closed circle at the end there, the coordinates of that point are 8, comma, and then we went up 10. So 8, comma 10. This is the x value, and this is the y value, or this is x, comma, f of x. So when we plug in an 8, we get out a 10. So if you plug in an 8, you get out a 10. And again, you can kind of see the ordered pair right there. So that's how that works. We literally just say, okay, I'm going to go to 8 on the x-axis, and then I'm going to go figure out what the function value is. Where is the graph? Is it up here at 10? Is it down here at -2? Exactly where is it? So let's take a look at the next one. The next one's slightly different. This one is a line that goes down from left to right, but again, we'll assume that it continues in that direction. So if we're finding the domain is going to start right here at, looks like -6, squishing these up here, and again, continuing like that. So this is going to be from -6, and we could go as far as we want in this direction for the domain. So that's going to go all the way to infinity. But then we've got a question here. Now the last one had a closed circle. This one has an open circle. So what that means is -6 is where the domain starts, but it is not included in there. So there actually isn't a function value at -6. That's an open circle right there. And then we want to do the range. So the range, we're going to go like this. Okay, squish it onto the y-axis, squish it onto the y-axis. Again, we could continue going down here. So this is going to start at -infinity, and it's going to go all the way to right there, which looks like about 9. So we'd go from -infinity all the way to 9. And again, 9 is not actually included because that's an open endpoint. So there's the domain, there's the range, and now we want to find f of -2. So if you want to find f of -2, here's what we need to do. We need to go to -2 on the x-axis. So -2 on the x-axis. Remember, this is f of x, and we want to find the y value there. So we're going to go to -2 on the y-axis, and then we're going to go either up or down. Well, right there, that's the point with an x-coordinate of 2. And that means the y-coordinate would be 1. So this point, -2, 1. Write that the right way. -2, 1. We plug in a -2, we get out a 1. That is f of x is the same as y. So when we plug in a -2 for the x, we get out a y for the 1. Or for, well, y, 1 for the y. Say that right. Okay, let's take a look at this next one. Now, this is kind of a unique graph. We haven't seen one like this before. So if we were to find the domain, we're basically taking all of these points, and this continues going up and out, so it kind of goes like that. Same thing over here. So we'd be able to take these points and squish them down here, squish them down here. So really, all of this is covered from these points that go up. And then we could squish these up here so everything's covered there, and I'm hoping you're getting the ideas. Okay, these would be squished down here. So the entire x-axis would be covered. So this is from -infinity to infinity. And with weird graphs like this, it does take a little bit of experience to realize, okay, that's just going to continue going up and out like this. So we might have to go way up here to get a point down here, but we could do that, and we could go way off the upper part of the screen to get one that's way over here and things like that. Now, the range is kind of interesting because we don't have any y values. There's nothing to squish onto the y-axis here. That doesn't start until right here, and it actually gets covered from both sides. So it's like this. So we don't start getting answers until, let me start down here. We start at -infinity. We come up here. No answers at -8. No answers at -4. Well, right here at -3 is where we start getting answers, and then we keep going all the way up. So this would be from -3 to infinity, always round around infinity, and then stop and give that some thought. Would we include this right here? Does it actually come down and touch that? Sure, looks like it does, so we'd put a square bracket around that. Now, the point that I just graphed is actually the one that we're after. We are after f of 0. So this is the x value. They're telling us that the x value that we want to find the function value for is 0. So we go to 0 on the x-axis, and then we either go up or down to find where the function value is. So in this case, we go down 1, 2, 3. So the point is 0, -3. So this is the x value. This is f of x. So x and f of x. Remember, f of x is the same as y. So that is -3. And again, you can kind of see 0, -3 sitting right there. All right, so that's how to do those 3 problems right there. And again, just to kind of emphasize, Can you see why we say f of x is equal to y rather than y is the same or equals f of x? If you put it in this order, there's your ordered pair right there. Okay, there's your xy pair. And we see that f of 5 is just asking something like this. It's saying when x is equal to 5, what is the y value? That's what something like that would be asking. So we're going to slide down here and take a look at example 5. And on this one it says, answer each of the following or state why there is a problem. So when they say answer, what it means is find the function value. And again, this is the nice thing about function notation. This says find g of -2. So find the function value when x is -2. So you'll notice that there's an issue here. In fact, we can't even really write this down as function notation for this particular graph because watch what happens. If I go to -2 on the x-axis, what we want to do is we want to say whether we go up or down or do we stay on that line for the function value. Well, there's a function value right there, so that would be -2, 0. There's another one right here, so that would be -2, 4. There's another one down here that would be -2, -8. And you'll notice that we've got an issue here. When you plug in an x, you get a bunch of different answers out. So this x corresponds to at least 3. In fact, there's an infinite number of y's that it corresponds to. Okay? So we're going to write NA, and we're going to write not a function. The reason we have an issue here is we can't say what the value is because there's so many different values to choose from, and that's why we like functions so much. We only want one answer every time we plug a number in. So let's take a look at the next one. We want to do h of 5, so we're saying that this is the x value right here. So we want to put a 5 in, so we're going to go to 5 on the x-axis, and then do we go up or do we go down? Well, again, notice that we could go up and we could get that point right there. We could go down and we could get that point right there. So this would be 5, 8, and this one would be 5, -8. And again, we run into that issue. Doesn't pass the vertical line test. My gosh, this was a vertical line. So we end up with an x that corresponds to two different y's. So we're going to write a big fat NA, and again, we're going to write not a function. This is not a function, so you can't evaluate function values for that. Now, if we take a look at this next one, this is an interesting graph. We've got a bunch of separate points here, a bunch of discrete points in this graph. And what it says is find find P of 3, new name here, P of 3. So that means we're going to go to 3 on the x-axis. So we're going to go over to 3, and then we need to go either up or down. Well, there's no points down here. There is a point right up here. So that would be the point 3, 8. So that means when you plug in a 3, you get out an 8, and there we are. So we can find that one. There's no problem with that whatsoever. Okay? All right, let's slide down here and take a look at this last little bit. So this is example 6. We also need to be able to evaluate functions when we're plugging in algebraic expressions. Now, this is going to be a bit of a brain stretcher. Sometimes this is just flat weird on some of these, but you do have a few of these on your assignment, and this really gets you used to some things that you're going to see down the road in math. So let's go ahead and give this a whirl. We want to find f of 3a. Well, remember, wherever there used to be an x, we want to put a 3a. So here's f of x. It's 2x plus 4. So if this is f of x equals 2x plus 4, that means wherever there's an x, we're going to put a 3a. So this is going to be 2 times 3a plus 4. So really, the only thing that we can do to simplify this is to just do the multiplication. So that's going to be 6a. And this is just 6a plus 4 because there's really no like terms that I can combine at all. And I know this seems weird, but this is kind of getting used to some of the abstractness that you're going to see later on. We don't always get numbers. We don't always plug in a number and get a number out. Sometimes we're going to plug in an expression with a variable and we get out an expression with a variable. So let's turn our attention to b here. This one we want g of -2b. Now a quick little warning right here. We're plugging in a negative value. It's super important that we plug things in parentheses to begin with. We really ought to do that all the time, but especially when they're negative. So on this one right here, g of x is x squared minus x. So here's what we're going to do. We're going to do something squared. So we're going to do that -2b, and we're going to square that, and then minus, and again, what we're plugging in is a -2b. So this is what we need to simplify. So notice where there used to be an x, we put a -2b. So where there used to be an x, we put a -2b, and where there used to be an x, we put a -2b. Now, we do need to kind of think about this for just a second. We're squaring negative 2b. So that means there's two negatives, two 2's, and two b's. So two negatives in a multiplication problem make a positive. So this is going to be 4b squared. And then we've got a negative times a negative. This is going to be plus 2b. So this means that g of negative 2b is actually equal to 4b squared plus 2b. No negatives in that answer right there. So I'm going to go ahead and circle this right here. That's the right way to simplify that. And sometimes we might even just circle this and say, well, that's the function value, or that's what the expression that we get out when we do that. But let's take a look at this last one. This is h of c, and here's the function right here. We've got x squared plus 2 on the top divided by x minus 3. As long as we're not plugging in a 3, that's totally okay. Those values would be in the domain. So here's what we do. I'm just going to draw that fraction bar, and we're going to put a c wherever there used to be an x. So this is a c squared plus a 2. And on the bottom we have a c minus 3. And here's the awesome thing about this. There is nothing else to do on this. We're just literally changing variables is all we're doing on that one. So that's the answer right there. So I realize some of this might seem a little bit weird. It does take a little getting used to, but make sure you ask questions if you've got them. Good luck on the assignment.